Hello everyone, this video is about solving indices. Find the value of x which satisfy the following equation: 5 raised to 2x minus 6 into 5 raised to x plus 5 is equal to 0. Now we are going to rewrite the equation as follows. We have 5 raised to x and then we bring 2 outside. Now I'm applying the law of indices that states that if you have a raised to m and then the whole of that raised further to n, then this can also be expressed as a raised to m times n. Remember, m and n are commutative, and therefore we can also have it as a raised to n inside and then m outside. So that is what I've done. 5 raised to 2x. 2x is just the product of 2 and x, so we can decide to bring x inside and then leave 2 outside. So in a while, we'll be able to understand why I've decided to have x within the brackets. And then we'll also have the rest of the equation as, so we have minus 6 times 5 raised to x plus 5 is equal to 0. Now this expression here enables us to apply substitution. So we are going to let 5 raised to x, you can see it common in these two terms here. 5 raised to x is here and it's also here. So we can let 5 raised to x be some unknown, so we can choose on the letter y, so that the first part here, when you substitute, we will have y squared and then minus 6 times y, this is y, and then plus 5 is equal to 0. The next step is to factorize this expression here, or this equation. Now, factorizing the left-hand side, we are going to apply a factor method. We are going to look for two numbers such that their product will be equivalent to the product of the coefficient of y squared here, which is 1, and the constant term, which is 5. So 1 times 5 is 5. And then their sum should be equivalent to the coefficient of y in the middle part, and that is negative 6. So the two factors are, well, we can always determine it as follows. We have the product as 5, so we're going to look for the factors of 5. We can list them. 1 by 5 is 5. 2 is not a factor of 5. 3 is not. 4 is not a factor of 5. And the next number is 5, and 5 is already here. So we have 1 by 5. So these are the only factors. Remember, 5 is a prime number, and therefore we can play about with these two factors here so that these conditions here are met. Now, if we make both of them negative, like negative 1 and negative 5, their product should be positive 5, and then negative 1 plus negative 5, that should give us negative 6. So the values here are negative 1 and negative 5. So we're going to apply these factors while replacing the middle part using these factors. We are going to have y squared. Therefore, we split negative 6y as follows. We have negative 1y, which is negative y, then minus 5y, which is negative 5y. So negative y minus 5y is still equivalent to negative 6y. And then we have plus 5 is equal to 0. Now we did this to enable us factorize by pairing. So we can pair this first part and then the last part. So when we pair, we can factorize here. Common factor is y. So y into y minus 1. And then here we have minus 5 is a common factor. So 5 into y minus 1, and then the right hand side is 0. Well, from here we can say y minus 1 is a common factor, so we factor it out, and then inside bracket we'll have y and negative 5. So we have y minus 5. The right hand side is still 0. From here we can say y minus 1 is equal to 0, and therefore y is 1. And also we can say for the other part, y minus 5 is 0, and that implies y is 5. At this stage, we'll have 5 raised to x is equal to y resurfacing. Remember, y is 1, and we had let 5 raised to x to be y. So in place of y, we can write again 5 raised to x is 1. And remember, a number raised to 0 is always 1. At this step, we are seeking to have the bases the same. So we'll have here 5 raised to 0, which is 1. Once again, the choice of the base here is determined by the base on the left-hand side. Remember, we have 5 raised to x, so the base here also has to be 5 raised to a number, and for this case 0, so that we have the result as 1. Well, whenever we get to a point where a raised to m is equal to a raised to n, now so long as the bases are equal and you are equating as shown, then you can as well just equate the powers. You can say m is equal to n. This is what we are going to apply here. So we have 5 raised to x is equal to 5 raised to 0. The bases are equal, and therefore we can conclude x is 0. Applying the same here, we have y is equal to 5 and y is 5 raised to x. So we equate that to 5. 5 is 5 raised to power 1. And referring to this again, we can say x is 1. And finally, the values of x are, so we have x is 0 or x is 1. And that is how we go about this question. Thank you for watching. See you in the next video. Bye.